Welcome, my friends! In this video, we will discuss how to complete a one-sample hypothesis test for the population mean using p-values. I have already provided an extensive introduction to hypothesis testing in 3 short videos, and I encourage you to check those videos out first if you aren't familiar with hypothesis testing. Links are in the description, of course. The procedure for testing a mean in a nutshell is formulate a hypothesis about the population mean of some variable that you would like to research, gather a sample from the population to see if the data is consistent with your hypothesis. This includes calculations involving probability and statistical distributions. If the data is highly consistent with your hypothesis, you will conclude that your hypothesis is most likely correct. Otherwise, you will dismiss the hypothesis. There are a number of assumptions required in order to complete a hypothesis test for the population mean. First, a random sample must be used to gather the data. Second, if the distribution of the data is normal, any sample size will work. Otherwise, the sample size must be at least 30. This is so that the central limit theorem will apply, meaning the distribution of x bar will be approximately normal. Third, if the population standard deviation is known, which is typically not the case, we will use the z-distribution. If the population standard deviation is unknown, which is more common, we will use the t-distribution. The procedure is almost identical for using the z or t distribution. The only difference is the calculation of the test statistic and p-value in step 2. For the z-distribution, we use this formula for the test statistic, and for the t-distribution, we use this formula. In the t-test statistic, we use the sample standard deviation s, as the population standard deviation sigma is unknown. Recall that in order to use the t-distribution, we also need to know the degrees of freedom, which are the sample size n minus 1. We will look at examples using both distributions in this video. Let's take a look at our first example. Suppose the mean age in America is 38 years old. Sam believes that the mean age in Florida is higher than 38 due to the large number of people who moved to Florida after retirement. From a random sample of 225 Floridians, Sam finds the mean age to be 40. Based on past studies, Sam knows the population standard deviation age in Florida is 15 years. Is there sufficient evidence to suggest that the mean age in Florida is higher than the American average of 38? Use a 0.05 level of significance. Before we do anything, let's first list some of the important given information. The stated mean is 38 years old in America. Therefore, mu sub 0 is 38. The sub-zero is used to signify that this value corresponds to the null hypothesis and is the value we will be testing our data against. The sample mean x bar is 40 and the sample size n is 225. The population standard deviation sigma is known to be 15. Note that we have met the assumptions of the test, as firstly, we have a random sample, secondly, we have a sample size much greater than 30, and thirdly, we know the population standard deviation, which means that we should use the z-distribution in order to complete the test. If the problem did not state that we knew the population standard deviation, and we only knew the sample standard deviation, then we should be using the t-distribution. Alright, now we are ready to go through the 3 steps of the hypothesis test. Step 1. The null and alternative hypotheses. Every hypothesis test will contain both a null and alternative hypothesis, represented by h sub 0 and h sub a. Since we are testing a population mean, the first part of each hypothesis will be mu. I like to start with determining the alternative hypothesis in most cases. If we reread the first few sentences, we notice that Sam believes the mean age of Floridians is higher than the mean age of Americans. Higher suggests greater than, meaning our alternative hypothesis should be mu is greater than 38, the average age of Americans. The null hypothesis will always contain an equal to sign, so we have mu is equal to 38 in our null hypothesis. We know we have a right tail test, as the alternative hypothesis has a greater than sign. Step 2. Calculations. We have already determined that our level of significance is 0.05. Next, this is where our decision to use the z-distribution will become important. We must calculate a test statistic, which is just a number calculated based on a sample in a hypothesis test in terms of the corresponding distribution, in this case a z-score. The z-score can be found by taking x bar minus mu sub 0 divided by sigma over the square root of n. Plugging into the formula, we have the following. Typing into the calculator, we want to put parentheses around the numerator and denominator. So we have open parentheses, 40 minus 38, close parentheses, divided by, open parentheses, 15, divided by the square root of 225. Arrow over to get outside of the square root, and then close parentheses. When you press enter, you get 2, so the test statistic is z equals 2. If we draw the standard normal z distribution, we know that a z-score of 0 corresponds to the mean, and we just calculated that the test statistic is 2. We need to calculate the p-value now, which is the area in the tail, which I've shaded in green. We could calculate the p-value using probability tables or computer software, but today I will be using the TI-84 calculator. To calculate the p-value using a z-distribution, we press second, distribution under the vars key, option 2 for normal CDF, and then we are asked for the lower and upper bound. We will be entering in z-scores into the calculator, and need the lower and upper bounds of the shaded area on our graph. The lower bound of the green shaded area is our test statistic of 2, and the upper bound is, well, there is no upper bound. The shaded area technically goes off into positive infinity, but if we put a very large number, like 1,000, that represents 1,000 standard deviations, and will be plenty large enough. Leave the mean at 0 and the standard deviation at 1 for the standard normal z distribution. Scroll down and press paste. On a TI-83 calculator, match this output. Normal CDF, 2, 1000, 0, 1. Press enter, and we get the p-value of 0.0228. I generally like to round the p-value to 4 decimal places. This is the area in the right tail of the distribution, and is the probability of sampling a sample mean of 40 or greater, assuming that the null hypothesis is true. Step 3. Decision and conclusion. If the p-value is less than or equal to alpha, we reject the null hypothesis, and if the p-value is greater than alpha, we fail to reject the null hypothesis. As I like to say, if the p-value is low, the null has to go, and if the p-value is high, the null will fly. Anyways, the level of significance alpha is equal to 0.05. The 0.0228 p-value is less than or equal to 0.05. The p-value is low, so the null has to go. So the p-value is less than or equal to the level of significance, and we therefore reject the null hypothesis. For the conclusion, we say that at the 5% level of significance, there is enough evidence to suggest that the population mean age of Floridians is greater than the American average of 38. If we would have failed to reject the null hypothesis, the conclusion would be identical, except is would change to is not. Notice this phrase corresponds to the alternative hypothesis, mu greater than 38. Alright, let's try a similar problem, but let's change it up a bit. Instead of comparing the average age of Americans to that of Floridians, let's compare it to Michiganders. This time we believe the mean age of Michiganders is different from the American average of 38. Our sample consisted of 25 Michiganders with a mean age of 34 and a sample standard deviation of 20. This time the standard deviation was calculated from a sample and is therefore S, the sample standard deviation. Let's go through the 3 steps again. Step 1. The null and alternative hypotheses. Again, I like to start with the alternative hypothesis. Notice that this time, we aren't sure whether or not Michiganders live longer or shorter than Americans. We just think there's a difference. That means our alternative hypothesis must be mu is not equal to the American average of 38, and the null hypothesis will be the opposite. Mu is equal to 38. Since the alternative hypothesis has a not equal to sign, we know we have a two-tailed test this time. Step 2. Calculations. This time we should use the t-distribution because the population standard deviation is unknown. We only know the sample standard deviation, S. Since we are using the t-distribution, we must use this formula to calculate the test statistic, which is essentially the same formula that we used last time, except we use s instead of sigma in the denominator. We have 34 minus 38 divided by 20 divided by the square root of 25, which comes to -1. This is our test statistic. This time we graph the t-distribution, which is symmetrical, just like the z-distribution. The mean of a t-distribution is 0. We must plot our test statistic of -1, but we must also plot +1 since we have a two-tailed test, which is indicated by the not equal to sign in the alternative hypothesis. The p-value will be the combined area of the two green shaded tails. Instead of finding the area of each tail individually, we can find the area of one tail and multiply by 2, as the distribution is symmetric. To find the p-value on a TI-84 calculator, we can press second, distribution, option 6 for TCDF. The lower bound of our shaded area, if we are solving for the left tail, is -infinity, so we can put -1000, and that will be small enough. The upper bound is our test statistic of -1. The degrees of freedom are n-1, which are 25 minus 1, or 24. Pasting, we have TCDF -1000, -1, 24. Match this output on older calculators without the previous menu. Press enter, and we get 0.16364 approximately. This is the area in each of the two tails. To find the combined area of the two tails, just multiply this number by 2, and we get 0.3273, rounded to 4 decimal places. This is our p-value, which is the combined area of the two tails. Step 3. Decision and conclusion. The level of significance is 0.05. 0.3273 is greater than 0.05. If the p-value is high, the null will fly, meaning we should not reject the null hypothesis. As the p-value is greater than the 0.05 level of significance, we fail to reject the null hypothesis. The conclusion is that, at the 5% level of significance, there is not enough evidence to suggest that the population mean age of Michiganders is different from the American mean of 38. We use is not as we failed to reject the null hypothesis, and this part here represents the alternative hypothesis in words. And we are done. All right, my friends, that wraps up our discussion of the one sample mean hypothesis test. We will be exploring many more fun and exciting statistical topics that you won't want to miss, so make sure to check out our other videos.